I'm volcanologist Jenni Barclay. This is Volcano Support. At Serene B. Russell, not gonna lie, the most jarring part about being in Italy was casually being told what looked like a normal mountain super close to where we had been staying was Mount Vesuvius and that it was still active. Excuse me? She's absolutely right. It is still an active volcano. And in fact, the last time Mount Vesuvius erupted was in 1944. And like many volcanoes, we tend to hear about them in the news when there's lots of activity going on, they have a huge impact. But at any one time around the world, we manage to live quite happily with about 40 to 50 volcanoes erupting anywhere on the Earth. It is true that for Naples, Mount Vesuvius having another eruption would be a big deal. Sometimes it has a really large eruption like it did famously burying Pompeii and Herculaneum. Sometimes it has an eruption like it did in 1944, where it generated a relatively more quiet lava flow and a few smaller explosions. And Mount Vesuvius is capable of generating both of those types of eruptions. Okay, this question is from JZA Siana. God just be making pointless ass. Why the do volcanoes exist? Volcanoes do seem a bit destructive, but actually over geological time, volcanoes first formed, and what they did is they transported a lot of really useful things like water and oxygen from the interior of the Earth to the outside of the Earth. So to be honest, without volcanoes on the Earth, we wouldn't be here either. At El Caprich says, there's a volcano in Indonesia that spews blue lava. I mean, what sorcery is this? Blue's not really a colour that you'd associate with volcanoes, it's red. But the blue is a really special condition for that particular volcano. It's really full of sulfur. And when that sulfur erupts, as the lava's coming out, it's not the lava itself that's blue, but it's the gas that's associated with it. And it creates this ethereal blue flame that really does look pretty spooky over the top of it. So the next question's from @1airbruff18. Why are Iceland volcanoes so active? So Iceland is an island sticking out in the Atlantic Ocean, and Iceland is there, just like Hawaii, because of the huge amounts of volcanic activity over time. And that volcanic activity has meant that that has built up from really deep in the seafloor and now sticks above the ground. And unlike Hawaii, Iceland is also located on a rift, so where the plates are moving apart like that. So what that means is there's two different mechanisms that help to generate that magma, and every now and then that magma has to make its way to the surface. And that's why their volcanoes are so active. So this question is from @moravagin_lol. What do volcanologists even really do except sit around talking about how badass volcanoes are? What else is there to be studied? They're volcanoes. Slightly rude. What I spend a lot of my time doing is I like to look at rocks. They're the secret recorders of some of the things that have happened to the magma before it erupted. And it unlocks lots of clues about how volcanoes are going to erupt. And this is basically frozen magma. And by examining this, we can understand what sorts of things were in the magma that caused it to erupt. Volcanic rocks are also erupted with crystals in them. You can maybe just about see the crystals now in this magma here. And believe it or not, crystals grow with very specific composition that we can use to unravel the pressures, temperatures, and the changes that happened that caused that magma to go from being nice, gentle magma sitting around quietly underneath the Earth's surface to something that erupts and causes destructive mayhem that we associate with volcanoes. One of the really big challenges we've got as volcanologists is the warnings for us are understanding when that magma underneath the surface is on the move. And these are my modern measuring devices, if you imagine. And what we can do now is imagine in the subsurface, we've got these areas where magma might come through. Now, as the magma pushes up here, you can see it's starting to push and go where it otherwise wouldn't have been. So it creates all sorts of tension in the rocks around there, which create little waves that we can pick up with our splendid detecting devices. And we can tell how those waves have been generated and what's going on with that. And the other thing that happens is as the magma starts to push up, it actually makes our little volcano start to deform and it will change its position, which would mean that also what we can measure from, well, here's my funky satellite here, what we can measure by satellite is changes in the surface of the Earth. The next question is from Brabot747. My question is, what's your favourite volcano? Mine would be Mount St Helens. My favourite volcanoes are all called soufrières. I've done huge amounts of field research in the Eastern Caribbean. The little islands there are a line of volcanoes, and many of them have the name soufrière in their title. So I love Soufrière St Vincent on St Vincent and Soufrière Hales Volcano, which is on Montserrat. When these volcanoes erupt, what they do is they produce spectacular explosions, and sometimes they erupt slowly and gently. Not the red hot lava flows that you might expect, but build up of dome material at the top of the volcano. However, when those collapse back down, they generate deadly pyroclastic density currents, mixtures of red hot ash and gas, and they come flying down the hillsides at speeds that are much greater than certainly than you can run from, and almost definitely that you could drive from. And these are something that are lethal for anyone who's in their way. At Han I-17, how are people standing so relaxed near 4 live volcanoes in Iceland? Volcano tourism? So unreal. Volcano tourism isn't a new thing, but if you remember the idea of the Grand Tour of Europe, and one of the things that many tourists would do 200 years ago is they would go and visit the amazing volcanoes of Italy, including Stromboli and Etna, which are frequently erupting, and of course the amazing spectacle of Vesuvius and Pompeii near Naples. And one of the things that they can do that's really frightening is they can erupt explosively and suddenly. And this can and does catch people unaware. Make sure you follow really closely official advice about that volcano. At Katie Nicholson 1 is wondering, where is the biggest volcano? Define big. So if by big you mean the tallest, one of the tallest volcanoes are actually Mauna Loa and Mauna Kea in Hawaii. The remarkable thing about them is they've got about 4,000 or 5,000 meters worth of height below sea level. They've had to build all that way up from the seafloor, and then they've got another 4,000 meters on the top. So once you count that level of building, they're taller even than Mount Everest. Technically, the tallest volcano in terms of height above sea level, they tend to be in the high Andes, which is of course a very high mountain range. And they're over 6,500 meters. And the big tallest volcano in the world in that sense is Nevada dos Ojos del Salado. Another way of measuring how big a volcano is how big the eruptions that it produces. So of course, there are the supervolcanoes, none of which have erupted in living memory, but historically, the largest volcanic eruption was Mount Tambora in Indonesia, which erupted in 1815, and that created noises that were heard in Australia. At Taylor McPee says, forgive me, he's forgiven, but what makes a volcano a supervolcano? Is it when multiple volcano eruptions combine, like a perforated ulcer? So strictly, what makes a volcano a supervolcano is when it has a super eruption. And your imagery of a perforated ulcer is kind of a little bit right in terms of all sorts of magma coalescing and coming together to create a huge volume of material that would be erupted out all at once. And a super eruption is when you have 1,000 cubic kilometers of material erupted all at once from the interior of the Earth outside. And luckily, that's something that really doesn't happen very often. At Erin's Wonderland is wondering, why do volcanoes have different shapes? And what plate boundaries do you find at each? Someone help, Google ain't helping. Stratovolcanoes tend to have much steeper slopes, that kind of classic volcano shape that we think of, whereas shield volcanoes tend to have much lower angle slopes. In different types of plate boundaries, there is a tendency for particular types of magma to be generated. So in the subduction zones, where we've got one plate going underneath the other, big explosive eruptions create lots of material, and so they pile up quite quickly, creating what we think of as the classic volcano shape. And in areas where you've got more gentle flows, you'll have more shield volcanoes. At Abby Smith wants to know, what has been the longest continuous eruption? Stromboli, for example, an island off the coast of Italy, has been erupting for thousands of years. It has little explosions. Even the Romans used to refer to Stromboli as the lighthouse of the Mediterranean. And it's had a few pauses that mean it's not the one that's thought of as continuous. But the volcano that we know that's been going the most continuously is Santiaguito volcano in Guatemala, which has been erupting continually since 1902. At a wasted hour is wondering what country has the most volcanoes, active and extinct. The United States of America, which has got many volcanoes in many different states along the west coast. But in fact, I would say the country with the most active volcanoes, so where, for example, there are 7 volcanoes erupting right now, is Indonesia. And that's definitely the country that's had the most volcanoes that have erupted since, for example, 1950. So at Blah wonders, supervolcano overdue for an eruption could wipe out the whole US. Bitch, what? I think what you're worrying about is perhaps the supervolcano that you find in the US, Yellowstone. Its supervolcanic eruptions are about 300,000 years apart. And to be honest, supervolcanoes don't always have supervolcanic eruptions. And what Yellowstone most often does is it has much smaller eruptions. Supervolcanic eruptions, so ones with those huge volumes of material, happen really, really infrequently. We're talking many thousands of human lifetimes apart. So at Jedi Master Roman, trying to wrap my head around how volcanoes can cause tsunamis is wild. You're right. In the case of volcanoes, when they erupt, a huge amount of material that all comes back down into the sea at once, that creates the displacement that can generate a tsunami. But the other thing is that volcanoes build themselves up chaotically, and from time to time they can completely collapse. So if a volcano collapses down into the sea, then it can generate a tsunami as well. So most recently, there was an eruption of Anak Krakatoa, and it had a big eruption that generated a tsunami, and that inundated many of the villages nearby. At Red Erin is wondering, what's the dark, glassy volcanic rock called? It's called obsidian. It's absolutely fantastic. If anyone plays Minecraft, you might have seen this. This is real obsidian. And this is actually from the island of Lipari off the coast of Italy. And what this is volcanic rock that was magma, where the melt has quenched so quickly, it hasn't made any crystals, but actually turned itself into glass. And if you took a tiny little shard off this, you would almost be able to see through it. It's also very, very sharp. It was used by many cultures as a cutting implement. So for example, Native Americans in South America, the Maori in New Zealand, pretty much anywhere where they could access this really special type of volcanic rock. So at ProBucks asks, weather dummy here, how do volcanoes cause lightning? So volcanoes cause lightning separate to the kind of lightning phenomena that we see in the atmosphere, because when we have an explosive eruption, huge amounts of ash is thrown out into the atmosphere, and that's actually electrostatically charged. And so the differences in charge across the plume that's generated by that explosion create lightning. At Quiet Bat People is wondering, why do volcanoes become inactive? And that's an easy answer. Volcanoes become inactive when it runs out of magma that can get up to the surface. We either think of volcanoes as potentially active, which means in the process of erupting, or extinct. So dormant, I think, really means when you think it could erupt again, but it might not. And we tend to refer to those as potentially active volcanoes. And round the world on land, there are about 1,400 of these volcanoes. At Cassie has got a really interesting question. Questions from 5-year-olds. What would happen if I fell into a volcano? So if you fell into the crater of an active volcano and say, for example, it had a hot lava flow in the crater, that lava flows at about 1200 degrees centigrade, so super, super hot. So certainly a temperature at which it would be very difficult to survive for very long at all. This is an interesting question from @Mackenzie Turman. If volcanoes create new land, how did the first volcano come about? Almost philosophical. Actually, magma was first. Believe it or not, when the Earth was first formed, it was a giant ball of magma. And actually, it was as that started to cool down slightly that land was able to be formed. So the volcanoes were absolutely definitely first, but the planet was one giant ball of magma. And it wasn't until it created the land that the volcanoes had to start pushing out through that land and forming. At Silver Dreams, I just thought of something. If sea levels can rise and undersea volcanoes erupt to create new land masses, does that mean Earth is gradually becoming a bigger sphere over time? Can you answer this? Well, Silver Dreams, that's a really good thought. So if we're thinking about things erupting and moving apart like this, then you would think that over time the Earth would be getting bigger. But actually, because of plate tectonics, these plates are growing and moving like this, creating new landmass. But at the same time, at the other end, there's plates that are going down underneath one another and destroying them. And both these areas are where volcanoes can be created, but they're what it means that over time, the Earth has remained the same size. The next question is from @Ira Cook. How does volcanic ash from South America stop flights to Melbourne? Pretty amazing stuff. I'm hoping my flight makes it. So perhaps you will all remember when flights were stopped in 2010 from Eyjafjallajökull, and that was a really unfortunate circumstance of atmospheric circulation that was pushing ash towards Europe, so they had to close European airspace. And that's of course because there's all sorts of different types of atmosphere circulating. And once volcanic eruptions are sufficiently big that they inject material up into the upper atmosphere or the stratosphere, that ash and those particles get travelled all around. And guess what? Aeroplane engines do not like those particles. They operate at temperatures that will turn that volcanic ash back into, if you like, magma, stick to the propellers, which is really not a situation that you want if you want them to keep going round. So, for that reason, when there's volcanic ash in the atmosphere, airplanes will avoid it. So at K. Olsen JD, do volcanoes communicate with one another? So it's not like in the Disney film Lava, where the volcanoes sing nice little songs to one another as they grow and fall back into the sea. But it is possible that when magmatic systems are close together, so the volcanoes at the surface are close together, their feeder systems, as there's things moving around in one system, the resonance and the pushes and the shoves in the ground get transmitted to another. So it's not that they'll erupt all one after another, but it's possible that some of those stresses and strains that we see in the subsurface do travel from one system to another. So at Jess Phoenix 2018 is wondering, have you heard any of the volcanic infrasound recordings? My colleague Jeff Johnson at Boise State records the sound volcanoes make below the range of human hearing. It's captivating. Yes, I have heard those infrasound recordings and they are captivating. So when volcanoes erupt, they cause all sorts of displacements and movements in the atmosphere and in the rocks that surround them as the magma is moving up. And these generate waves. And the infrasound waves, when you change their frequency, can be turned into sound waves that give an amazing record of some of these processes that are taking place. It's well worth checking out. At Matthew CR has the question, when it comes to geological terms, what is the Ring of Fire? Where is it in terms of plate boundaries? So here we go. This is a map of the Earth. And these white dots show the plate boundaries of the Earth. And you can see marked really clearly around the Pacific Ocean here, we have this big run of plate boundaries. And they all happen to be the plate boundaries where one plate is going down underneath another that generates quite a lot of explosive volcanism. Hence the name Ring of Fire, because there's lots of volcanoes all around this plate boundary and it surrounds the Pacific. Okay, so at J. Humphrey, ever wonder why some volcanoes like Mount St. Helens erupt explosively while others like Kilauea ooze lava? One of the things that's really amazing about volcanoes around the world is there's all sorts of different types of magma. And these different types of magma lose and grow gas within them in different ways. So for example, this is a magma that's a little bit more like what you might see in Kilauea. And you can see it's got these great big bubble holes. And that's because the gas can move around quite freely in the magma. But other types of magma are kind of quite resistant to that, and they create lots and lots of tiny little bubbles, which creates huge pressures that mean when the volcano finally explodes, there's a huge release of that pressure, generating very large explosive eruptions. And those large explosive eruptions generate something like this, which is pumice, which is super light. And the reason it's super light is because it's absolutely full of holes, which are a record of that gas trying really hard to get out, being resisted by that type of magma. But I'm going to put this into the beaker and it's going to float. And it's floating because it's super light, because it's largely composed of bubbles with just tiny little filaments of volcanic glass. Okay, so at E. Batterson is wondering, where do volcanoes get the magma/lava? Now, lots of people think there's a huge sea of magma just below the crust. That's not true. There's not magma everywhere. It's particular conditions that are created to generate that magma. And I'm going to show you this for a subduction zone. So here's one plate. It's diving down. Here's another plate here crashing into it. Okay. Now what happens is as that plate goes down, it gets heated up and squeezed, and it gives off fluids, and those fluids create the special conditions where melt can be generated. Now that melt has got liquid in it, so liquid rock if you like, but it's also got gas and it's hot. And what that means is that melt has a tendency to rise, and as it rises up towards the surface, it'll come out, and then eventually what we have is our volcano. I've been loving your questions from the internet. This has been Volcano Support signing off.